Hi everybody, Dave Coulson, Applications Manager at Zilog. What I'd like to show you today is some quick start guide through our development kits to help you get up and running with these kits as fast as possible when they come out of the box. So what I've got here right now is one of our evaluation boards. This one happens to be the Z8F082A evaluation board, which is part of our Encore XP family. A debug cable, also called a smart cable, and then a power supply. All this is included in the kit when you get it, when you buy it from one of our distributors. Along with that, you would get a CD and other documentation and such. This is all the important stuff that we need to work with today, so that's what we'll start with. So the first step usually is to load ZDS2, which is our IDE, our development system, onto your computer. The kit comes with a CD, but I always suggest to our customers that that you go to the web and make sure you get the latest version of it. So the easiest thing to do there is just simply to go to the Zilog website, which is www.zilog.com, and navigate into, under the Tools and Software section, Software Downloads. And then you'll see under Software Downloads, the very first item on there will be the ZDS2. This one happens to be 4.11.0. We're always updating this software, adding new features, making fixes and such to it. So that's why it's important to go to the website and make sure you get the latest one. So this is the IDE. And over here to the right, you'll see documentation. This is another good thing to download as well. This is a complete file that includes all of the Zilog documentation, product specs, application notes, briefs, everything that you need to get going, and would include, of course, documentation for the Z8F082A as well. So let's download this file just by clicking on it. This whole process should not take much longer than a couple of minutes to install the whole thing. So we've downloaded it, it's there, now we'll run it. And do a complete install. This takes about 60 seconds. Terms and conditions. I just always use the defaults, that's the simplest thing to do. And away it goes. Once the installation is complete, you'll be given a couple of choices. One to run ZDS2, and the other to look at the README file. It's always good to look at the README file. There's actually a lot of good information about the current release of ZDS2 in there. So we'll take a look at it right now just to see what type of information is in there. Starting at the top, there are changes from the previous revisions, which is important. So if you're coming off an older revision of ZDS2, this tells you any of the differences that you might see, including bug fixes and such. More importantly though, down the bottom, precautions and limitations. So these are some of the either known issues or just precautions that we found customers have run into, issues that customers have run into, not necessarily bugs with the tool, but just things that they have found that may cause some problems. So a lot of good useful tips and tricks in here as well. And then the change requests that we've closed. So if you were running into an issue on an older version, this is the place to go and look to see if that particular issue has been solved. So it's always good to look at this README file and just take a quick glance at it after you've done the install. So what's happened here is ZDS2 has opened up. It's installed, it's opened up, and it's basically ready to go. So what I'd like to do now is we're going to take this board, our evaluation board, the F082A board, and we're going to plug it in. As it comes out of the box, it's pre-programmed, so it has some demo code built into it. It's an LED blink type of demo. Basically, it's just going to drive these three LEDs here in sequence. Okay? So I'll just take my power supply that comes with the kit and plug it in. Plugging it in, now you can see the three LEDs just sequencing through. And the whole point is that if I push the test button over here, they'll start sequencing the opposite direction. So not a lot going on there. The way the code is written, we'll walk through it in a second, but it's interrupts and such that are running to make this happen, timers. So there's actually a lot going on inside of the part to make this happen, although there's not a lot going on outside of the part. Okay, so that's basically the demo. The board, when you get it, should come up and should be able to do this straight out of the box. Okay, that's that. The next step is to take your debug cable and install it. So when you first plug it in, Windows is going to recognize it as a new device and going to want to install some drivers for it. So we plug it into it. Windows finds some new hardware. And actually one little note there, what you'll find is that that even if you install if you used a USB cable in the past and you install a new USB cable, it will still recognize it as new hardware. That's not a bug or anything. That's what's expected to do. So don't be alarmed if that happens. So we'll install it automatically. It should be able to find the proper files for it and install the correct driver for it. Just so you know, the drivers were included in the installation of the IDE that we just did. Okay, so that's in. That's done. I see the nice yellow LED on, and we're good to go. Okay, so next we got ZDS2 going. We have our debug cable installed and the driver installed. Now let's take a look at some actual useful projects here, like the LED blink and such. So if I go into File and I say Open Project, there's a whole host of options here that we'll go through later, but first thing we'll do is we'll open the project. Now where you need to navigate to is under the C drive, Program Files, Zilog, through the installation version of ZDS2 under Samples, and all the way down to LED Blink. If I back up here, you'll see that when you install ZDS2, it actually includes the samples for all of the different products. The one that we're interested in at this particular point is the Encore XP, which is the F082A. And then under each of these, there's actually a C version and an assembly version of each of the demos. So you can see that we have it for the 4K parts, for the 8K parts, and for the 8 pins specifically, and for the 20 and 28 pins, what these are. So we give examples in both in C and in assembly for this. In this case, this is the 28 pin device, and it's an F082A. So what I want is this one right here, and that will show me the C version of it. So I'll go into this project, and under the source file, there'll be a project file called LED Blink, and I'll open that up. And this is what you should be looking at. Now when you first install ZDS2, a lot of the options are defaulted, and the first thing I usually do is I would go into this area here where you can see my mouse pointing to it. I right click and it gives you some options, and the one I usually select is workbook mode. And what you'll notice about workbook mode is it opens up some tabs down here and just makes it a little bit more friendly to use. So what we're looking at right now is the main file, main.c. Over here you have the project files. This will be your editor, and then down in the bottom is all your outputs and such. And you have different tabs for these types of outputs depending on what mode you're running in. If I page down a few times, I can get into the main program, the main routine, which is down here. And this is all the work that's being done. So you can see that the LED blinking is actually done through case statements in this case. It's a cheap and easy way to do it, which is fine for this example. Okay, so I have my debug cable plugged in, I have my project opened up, and I have power applied to my board. I'm basically ready to go. One little trick, I just want to go through these menu options with you, but under the project settings folder, this is the most useful folder or menu option that you'll find in ZDS2, because this is all your project settings. This is where you'll set up your C compiler and your optimizations and everything else. Okay, you have the general tab. This is where we select the family and the particular processor and such that you're working with. If you, for example, were to select a smaller part like this little 1K part, and the project did not fit into 1K, you would get the warnings that would be associated with that. So what we're dealing with here is a 4K part, this one here. Okay. Down a little bit further, you have some specific options for assembly. Usually this jump optimization is always checked. What that means is if the assembler figures out that an absolute jump can be turned into a relative jump, it will, because they execute a little bit faster and take a little less code. Under the C compiler, we have code generation, and this is where you may want to play with things a little bit to get the best operation for your particular application. Safest means basically no optimizations whatsoever. There are some inherent optimizations in the compiler, but safest means very little optimization. It's not going to try to optimize the code. It's going to basically compile everything you put in there. If you do small and debuggable, that means that there will be some optimizations, but we'll leave it very debuggable. In other words, we won't try to reuse memory locations and things like that in the compiler. Small as possible means that everything's in. You're going to get a completely optimized application at this point. And that may be something you want to do for release when you're finally done debugging your project. And then finally, user-defined, which is where you can go in and define the different memory models and such for this. So for example, memory model could be small or large. What that has to do is with how it addresses RAM, either in the first 256 bytes of RAM, or the further on 4K of RAM, and how it gets to those. And frames can either be static or dynamic. With static frames, your functions cannot be reentrant. With dynamic frames, they can. In these simple applications, they tend to be static frames. And then how you want parameters to be passed, either through memory or through registers. And depending on your application and your speed requirements, you may choose one over the other. Down at the bottom is the debugger. And there is one little hitch that I've found sometimes customers come across. That is when a new debug cable is installed, the system doesn't recognize it right away until you actually go into this debugger setting, click on Setup, select the debugger even though it's there, and click OK. So you actually have to physically say Setup, go in, select it, and say OK, and then it will find it. This doesn't happen all the time. This is some sort of Windows issue, but it's a fairly simple thing to get around. So that solves that very quickly and very easily. Some of the other options in here, like listing files, are fairly straightforward. Preprocessor commands, and some advanced where we do some deprecations in this area here. So for example, ANSI promotions, and where we put our variables in ROM. The linker, typically you would just simply use the linker settings that are generated from the settings themselves. If you want, you can click on this and add your own special linker directives, and obviously read the ZDS2 linker manual to find out what options are available for you there. And then this is how you would handle objects and other libraries if you wanted to add libraries into your projects as well. Address spaces. So there's three areas in this particular part. There's ROM, this is the flash, this is the program space where the code goes. In this case, it's a 4K part. We have R data, this is register file data. This is usually from 0 to 256 address, or FF address. And you'll notice that we actually block off the first 32 bytes of register data. The reason for that is the very bottom 16 bytes is used by the compiler for Scratchpad, and then the next one up is actually used for the first level of interrupts. You would move this to a 3, and another level nesting, you'd move this to 4. But with just a single level of nesting, you just leave that at 2, and that would be enough. And then E data is the RAM above 256. In this case, there's 1K of RAM, so it goes up to 3FF. So this is contiguous RAM, but the compiler treats it separately. And finally, warnings and then output. The IEEE 695 file is the file that's used for the debugger, and then of course if you want to create a hex file, you would click on this one as well. In this case, we've got them both in there. Okay, and that's about it. So I'll click on OK, and it's going to say you've changed some things, so it wants me to rebuild it. So I'll keep it happy, and we'll rebuild it, and off it goes. And there shouldn't be any warnings or errors or anything coming out of this in this particular project. It's perfectly clean. For example, if there were some errors, if I had some bad code, say right in about there, and I was building this thing. So there's a couple ways to build it, by the way. I can go here and I can say rebuild all, or I can just click on over here and say rebuild all, or just build. So let's rebuild all. Hopefully it'll find an error. It did, because I've got some bad code there. So I just go to the line item where I see the error and I double click on that, and then it should take me to around where the error is. Okay, so there it is. I'm going to clean up my bug, because all my bugs are that simple, and we should be good to go. And now I'll rebuild it again. Usually you just have to build and it will build all the affected files, but this, I'm just used to rebuilding all. It doesn't take much longer anyway. So there we are, we're good to go. Now we're ready to start debugging. Start loading it onto the board and debugging the code. So I'm going to take my debug cable now. I'm still plugged in to the power, and it's running. And if you look at the debug cable, there's a red wire, that's pin 1. There's also a marker on the debug cable that says bottom, and that means that goes on the bottom. So there's two ways to mark the way this debug cable has to be plugged into here. The debugger on this board is this 6-pin header here, and we're just going to plug it straight in. There it goes. LED light is still on. It looks like it should be good to go. So if I go over here onto my ZDS2, and I've got a few different icons that are the most useful here, and that is connect to target, download code, reset, and go. These are progressive in the sense that if I hit reset, it will perform the other functions first. So let's try and do that. Let's hit reset. And so it's initializing the communication, it's talking to the debugger, putting the chip into debug mode. Now it's loading the file into the flash, which shouldn't take very long, and it's done. And you can see my little yellow arrow is where my current program counter is, and the blue dots are basically what we would call valid code. In other words, if some code was conditionaled out, or optimized out for that matter, you would not see a blue dot there. So that's how I know that that is valid code. For example, here, this is all good code, but this does not exist because copy RAM is not true. So it didn't include that in the file. So what you'll notice though is that I'm in an assembly file in this case. This is the standard C startup file. This is the startup file that's included with all projects. It comes with ZDS2. It's just a standard startup file. It creates a C environment. It initializes all the initialized variables. It zeroes out the BSS and does any other work that's important. In the end, all it really does is call main at the end, right there. So that's how it gets to main down here. Sorry, call device, call main right here. So it clears out the registers and then calls main. And then main, of course, is in your own file. There is an option within ZDS2 to have it reset to main. So if you go into your options, you can tell it to just simply, every time you press reset, execute all of this, and stop you, I think would be to set a breakpoint. So to set a breakpoint is quite simple. You just double click on the dot there, and the red dot means there's a valid breakpoint there. One of the great things about this system and about all the Encore devices is that you have virtually unlimited breakpoints. I can have as many breakpoints valid and active at the same time. I can put them in interrupts, I can put them anywhere I want. There's no limitation to that, which is nice. So along here, I have reset, that's my stop debugging, and here's my go. So if you remember, my program counter was at the reset, which was in that assembly file. I've got a breakpoint set at the beginning of main, so in theory I should run through all that initialization code and then stop at main. So let's see what happens. So we come along, and sure enough, we stopped right at main, right at this initialization of this integer called LED state. So let me clear out these breakpoints and just verify that the whole program is still in fact working. So we'll clear out all these breakpoints. There's a way to do it automatically, but that was the fastest way for me. So if I just hit go now, I should see the same LED blink go on that we saw when we first plugged the board in. So I'm going to hit go, and let's take a look at the board then. So go, and sure enough, there are the LEDs flashing along like they used to. So if I hit that button, they should start going the other way. So code works in this case, which is good. I'm in debug mode. I could hit stop now, which is right there, which is break. And it will just break it wherever it happened to be at that given moment in time. And so the other options here, fairly straightforward. You can step into, step over, and step out. So in this case, I'm just about to go into an if statement to see where I'm doing. I'm not sure what's going to happen right now, but I'll step into this and off we go. And basically, there's nothing happening here. We're just sitting here with program busy. So the timers aren't expiring or anything on here. If I go over to this window here, actually if I show you up here under view, there's also the different debug windows that we can look at. View. The watch window is the most useful one. So that's the one that was up there. I just wanted to clear it out. So if you look at the watch windows, or locals for example, if I look at locals, it'll show me everything that's local within the particular function that I'm in at that given time. So for example, right now I'm in main, so the locals that are there should be LED state. And sure enough, LED state that is there, and it's a 1, and that's what it's doing. So the other thing I can do that's useful too is if I look at the watch window, now I can put global variables and other things in there that I want to. So if I go up to the top, I might see some global variables like prog stat right here. Another nice little feature is that if I just hover over that variable, it will actually show me the current value of it. So right now prog stat is a 0001, and it's an int. But if I want, I can include this as a watch. So there's my 1, it's there, and as you can see that this particular function is waiting on prog stat. If it's busy, so we'll make it a 0 and see what happens. Now we'll single step through it, and off we go into the push button routine, into the case switch, and so on and so on. So that's it. You're up and running. You're now debugging. Now you can go write your own code, and hopefully it goes as easy as it does for me on this one. Thank you.